So this is the no calculator section. I can do PQ for both of them, but I would prefer factoring. So I am going to solve this, find the roots by factoring. I can do my box. If I do my box, x, 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 negative 2xx. Circle the x's, x squared goes up here, x minus 2. And I come over here and I do my box. 4 times 1x, negative 4 times 2. Careful of the negative, then x minus 2. So I have x squared plus 4, these match, x minus 2. Okay, so now I set that equal to 0. And let me just show you, here's the match. And then there's the x squared plus 4. Okay. So now if I set the x minus 2 equal to 0, I get 2. And if I set x squared plus 4 equal to 0, subtract 4, square root, x equals plus or minus 2i. All right? I'll show you the PQ, because I know some of you want to see it. So if you don't want to see it, you're fast forwarding. So PQ, 1, negative 2, 4, negative 8. My possibilities, P plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. My Q is plus or minus 1, and then my P over Q is plus or minus, so I'm good to go. Okay? All right, so I'm going to cheat a little bit because I know 2 works. Bring down the 1. 2 times 1 is 2, minus 2 is 0. Just because I'm at 0 doesn't mean I stop. It has to be at the end that you get the 0. 2 times 0 is 0, plus 4 is 4. 2 times 4 is 8, minus 8. Boom, that works. Now here's the problem. You're going to, if you just rely on the PQ, you're going to try all of these and none of them are going to work. That's because these are all real answers and we know up here this is imaginary. So this was an x cubed. I took out an x. Now I'm left with x squared plus 0x plus 4, which is x squared plus 4, which is this pink, x squared plus 4, which gives you plus or minus 2i. So this is why factoring is helpful. Let's go to the next one. All right, I got too much happening. There shouldn't be another equal 0. So I know that I have no choice. I have got to do the PQ. 4, 3, 2, 1. Cool, nothing skips, so I don't have to insert any zeros anywhere. Okay. Since I have to do the PQ, I am going to test that you show me all the values of P, all the values of Q, and all the values of P over Q. Here, I didn't care about it. I wasn't testing you on that, but I'm testing that you can show me that you can do the PQ. So 1 over 1 is 1. It's the same thing. So it's plus or minus, or 1 over 1 is 1. That's covered. But 1 over 2 is 1 over 2 is 1/2. 2 over 1 is 2. We're good. 2 over 2 is 1. We're good. So really, these are my 3 choices. So I'll try 1 first. I'm going to highlight. Bring down the 2. 1 times 2, negative 7. Negative 7 plus 7 is 0. You get a 0, but you're not at the end, so keep going. 1 times 0. 1 times 2. Oh my gosh, it worked. It's amazing. I feel like it could be grouping, because that would be x cubed, x squared, x and a number. But this is positive negative, and that's positive positive. So I can't. So now I'm going to be a little bit adventurous, and I think I'm going to try negative 1/2. Why not? But that means this is my new yellow now. So bring down the 2. Half of 2 is 1. Negative 1 minus 7 is negative 8. Half of 8 is 4, positive, plus 0 is 4. Half of 4 is 2, negative 2. Oh my gosh, it worked. Now some of you go, you probably already knew the answer. Well, come on. I have a fraction in there. It probably means there could be some sort of fraction. So let's see. It started with x to the 4th. I took that out. It's x cubed. I took that out. Now it's x squared. You know me. As soon as it's x squared, I am going to factor it. But honestly, before I even factor it, I'd rather divide that by 2 to make it easier. And now if I try to factor it, I can't. So I have no choice. I have to do the quadratic formula or complete the square. I'll complete the square just for kicks. X squared minus 4x equals negative 2. A lot of you like this one. Half of negative 4 is negative 2. x negative 2, x negative 2. So this is 4, so you're adding 4 here and adding 4 there. Then you take this, x minus 2 squared equals 2, square root, x minus 2 equals plus or minus rad 2. Add 2, x equals 2, plus or minus rad 2. All right, look at me. I'm going to give you another opportunity for bonus. Oh my gosh. So your 4 roots are 2 plus or minus 2, 1, and negative 1/2. I will give you bonus if you know how to convert that into a decimal. So 2 plus square root of 2. Sorry, you can't see that. Let me zoom it in. So 2 plus rad 2, 3.414. So rounded to the nearest hundredth is 341. And then 2 minus rad 2 is 58, but it rounds up to 59.59. All right, that's how you can get some more bonus, which you can't see. I was so zoomed in on the calculator. Sorry about that. So if you give me this, this will be extra. All right. So I'm going to have to do some work here. Factored form. I'm going to start with factored form because it's already in factored form. Make sure if that says y equals, you write y equals. All right. I'm going to start doing my quick graph. That standard form looks a little bit horrendous to me, honestly. Ooh, I can do my x-intercepts. 1, 0, negative 2, 0, 3, 0, 5, 0, which means our roots are 1, negative 2, 3, and 5. So this got me the x-intercepts and the roots. I can get the y-intercept by plugging in 0, but if I already have to put it in standard form, I'll wait till I get that last number, and then I'll make that my y-intercept. Okay? All right, so we have a 1, a 3, a 5, and a negative 2. There's no bounces. It's x to the 4th power. X to the 4th power reminds me of x squared. X squared makes a u, so it's going to be a u. So I'm estimating here, okay? I don't know what I'm going to do, but I'll just fake it. That is my rough graph. When I figure out what my y-intercept is, I'll just make that my vertex because I feel like it, okay? So we'll get to the rest in a bit. I guess I should put it in standard form now. All right. There's a bunch of different ways to put this in standard form. I could do this times this, then times this, then times this. Or I could do this times this, and this times this, and multiply them. I think I'd prefer that. So if I box that out, I get x squared plus x minus 2. And if I box this out, I get x squared minus 8x plus 15. And then I'm going to do a 3 by x squared plus 1x minus 2, x squared minus 8x plus 15. Now, I will tell you, if you mess up on this, but you're consistently wrong with your, or right with your wrong answer, you won't get docked more than once. So make sure that I can find your work. I could definitely make mistakes. I'm going very fast. Remember the diagonals, go together, go together, go together. When it's x squared, x and a number. X squared, x and a number. So in standard form, we get y equals x to the 4th. Negative 8 plus 1 is negative 9x cubed. 15 minus 8 is 7, minus 2 is 5. 15 plus 16 is 31. And then minus 30. Okay? Because I'm making this quote as an answer key, I'm going to check real quick to make sure that I'm actually right. So I'm going to go home and I'm going to go to a graph. And then I'm going to graph my equation in or my function in standard form. Well, it's technically an equation, but it could be both. Now let me say again, if you get this wrong, but then you get right answers for this wrong graph, I won't ding you twice, okay? So I'm going to graph it, and what I'm looking for is that it crosses at, ooh, look at that. See, it looks like I'm off. So menu, window, trace, so I messed up somewhere. So let me go down. Oops. Shoot, I'm going the wrong, oh, I think I'm okay. Okay, hold on. So here's the problem. See how when I did the 0, it was negative 1.86, but my 0 was supposed to be all whole numbers. So I'm going to stop. Oh, I see my mistake. Negative 8 plus 1 is negative 7. Okay. Control G. Negative 7. Something probably all of you already saw, but you can't tell me on video. Okay. Now let's make sure it's good. Oh, awesome. Negative 2, done. 1, done. 3, done. 5, done. Now I'm perfect, okay? So I'm good in standard form, good way to check it. Now that means I know my y-intercept, okay? Which means I'll say this is negative 30. I've just decided that I want that to be my y-intercept. Since I've decided, I'm sorry, my vertex. Since I've decided I want that to be my vertex, I need to make sure I stick with it, okay? So I'm gonna make this a little bit lower because I feel like it, so that I can show a relative max and a relative min. All right, so this is negative infinity, positive infinity. This is positive infinity, positive infinity. Now I'm saying this is 0, negative 30, because I decided that was important. Halfway between 1 and 3 is 2, and I'll say 2, 10. I don't know, it's a positive number, who cares? 3 and 5, halfway between is 4. I just need to see how I made it lower than negative 30. So I'm just going to make it negative 40. And now we're good to go. Now, why am I doing that? I'm doing that for max and min. So if you look, my maximum is technically no max, positive infinity, but there is a relative max, which is 2, 10. You'll have more space on the test. My minimum is my lowest. There is a lowest value. This isn't my lowest. This is my lowest. If I wanted to, I could have made this one be up here, and then this would have been my minimum. Because then I could have said, oh, that's 4, negative 10, whatever I want. Okay. But since I stuck with this one, I'm going to be consistent. Okay. So my minimum, as we said, is actually this value, 4, negative 40. And there is a minimum. My domain is everything to the left, everything to the right, all real numbers, just like a quadratic, negative infinity to positive infinity. It's going up, so y is greater than or equal to. Well, it's greater than or equal to the lowest value. So that lowest value I decided was negative 40. Just be consistent. Negative 40, positive infinity, parenthesis. All right, intervals where it's increasing and decreasing. Intervals from here to here, it is decreasing. So negative infinity to 0. Then from 0 to 2, it is increasing. Then from 2 to 4, it is decreasing. And then from 4 to positive infinity, it is increasing. Look at that. 1, 2, 3, 4 intervals, because it's x to the 4th. End behavior as x approaches negative infinity, f of x approaches. As x approaches positive infinity, f of x approaches. Since they're going up, positive infinity. Okay. I think that's everything I need.